Hello and welcome back to Engineering in Motion. In previous lessons, we have always sent data from the Arduino to Python, like sensor readings, angles, distances. But communication can go both ways. Today, we are going to reverse the direction. Python will send data to the Arduino and the Arduino will display it on an I2C LCD screen. This opens up many possibilities. You can show radar alerts, object distances, or system status directly on a small display without needing a computer monitor. The Arduino becomes an output device driven by Python's decisions. So by the end of this lesson, you will be able to understand how I2C communication works, can connect an LCD using only 4 wires, display messages using Arduino, and most importantly, send commands from Python and display them on the LCD. But what is I2C? I2C is a communication protocol used to connect devices like sensors and displays. Instead of using many wires, it only uses 2 lines, SDA, to send data, and SCL for clock. This makes it very efficient and widely used in embedded systems. So instead of connecting like 6 to 10 pins like traditional LCD, we only need 4 wires. But now, before go any further, we need to address something important. Pi works over a serial communication protocol. It's excellent for digital pins, analog readings, PWM control, and something like that. But when it comes to protocol like I2C, things become complicated because I2C requires precise timing, continuous communication, and hardware level control. And Pi does not reliably handle I2C devices in a real project. That's why, the LCD doesn't respond, with Pi or if it responds, it behaves, inconsistently. This leads to a very important concept. Not everything should be controlled from Python. Instead, we design the system like this. Arduino will handle hardware, LCD sensors, motors, but Python sends commands and processes the logic. This is exactly how real systems are built. Think of it like this, Arduino, do just is like embedded controller, and Python is a high-level control system. What we will do instead, so instead of just forcing Python to control the LCD directly, we will let Arduino control the LCD using I2C, send messages from Python via serial, and we display those messages on the LCD. So this gives us, stability, simplicity, and professional design. But, don't think that it's just, about displaying a simple text on the LCD. This is the beginning of something bigger. Soon we will use, display to show so many other useful, informations. For example, if we want to use a DC motor, we can just show, all data like the PWM, like the speed, the RPM in future lessons. We can see all these things on our LCD, or we can see the sensor data or real-time system feedback and many other, useful informations. So it will turn our project into a complete embedded system. So let's get started. Alright guys, let me explain about today's hardware and the wiring. So, we want to connect our I2C LCD. So this is our I2C protocol, we only have 4 pins. And as you can see here guys, the first pin is the GND, the second is VCC, the third one is SDA, and the last one is SCL. But today you have to be very careful guys, why? Because we only can use 2 pins. You can use only pins A4 and A5, okay? But why we cannot use the other pins like the other A0, 1, 2, 3, or 3, only 4 and 5? these pins, I mean the pins 4 and 5, they are not just analog inputs. They have a dedicated hardware module inside the microcontroller. See, this is our microcontroller. Okay, so they have a dedicated hardware module inside of this microcontroller that handles all the precise timing, start-stop conditions, and data shifting that required by I2C protocol. So when we just include later in the coding environment, I will tell you, because we have to, one of the libraries that we have to import is the wire. So when we include the wire library and we use the commands, for example, the commands that we need to connect this LCD, there's lots of commands that we're going to use, for example, the init or other kind of commands. So the library will automatically use this hardware module by just only calling that library. So when we use these 2 pins, the hardware, the library will automatically use the hardware module. Okay, this is why your LCD must be connected to A4 and A5. I hope you understand what I mean. It's just very easy. Just for now, don't get confused, guys. I won't just explain more to you about why we have to use only A4 and A5, because if I want to just make it more advanced and explain more, you may just get confused. For now, only just remember, you can, because you have I2C protocol and you want to use your I2C protocol, you only allowed to use pins A4 and A5. Okay, so as you can see here in the 4 pins, SDA and SCL, we're going to connect the SDA, we connect it to like A4, and we connect the SCL to A5. Let's just connect it, guys. So this is the SDA. Okay, so this is the SDA. SDA, I said let's connect it to pin, for example, A4. Okay, so A4. And this is the SCL, the last pin. Let me connect the wire. Okay, so SCL will connect to pin A5, for example, the last pin. Okay, so these are the 2 pins. And like always, VCC means the 5 volts. Okay, or the positive. This is the VCC, and the GND will also be the negative. So I'm going to connect it to the negative row of my breadboard. Okay, so easy, guys. So this is the wiring. This is for the wiring of today's project. Just one more thing, guys, and don't forget, we only have to connect this. See, let me just turn it so you can see better. So the 5 volts and the GND of your Arduino board. So I'm going to connect the 5 volts to the positive, and I will connect the GND. Okay, GND I also connected to the negative part of my breadboard. So this is the whole wiring and the hardware setup for today's project. So we connected our I2C LCD and our Arduino board. So now it's time to go and just start coding. So in order to start coding, I will just begin with Arduino IDE. Let's open our Arduino IDE. Okay, so automatically and by default it will open the last program that you were working and you uploaded on your board. So I will just create a new file. Okay, just press Ctrl N on your keyboard or go to File. Here, guys, go to the file and just select the sketch, the new sketch. So I'm gonna close the previous lesson. Okay, so this is completely a new sketch. The first step, as so we have to just import new libraries today. But for today's project, for the I2C LCD, we need 2 libraries. So, one library, we don't need to install one of them, but we need to install one library. So in order to install a library, you already know, you go to the tools and you come to the manage libraries, or easily press Ctrl+Shift+I on your keyboard. And here in the search bar, exactly just type what I type here. So liquid, but liquid, the L should be in capital, so liquid, and after the liquid, press, type, capital C and say crystal, okay? So one more time, liquid with capital L and crystal with capital C without any space. And after the crystal, just put an underline and, with a capital I2 and capital C. Okay, so this one. So liquid crystal underline I2C. And when you just type this library name, you come down here, to this library. So the library, the liquid crystal I2C by Isaac Fatoni. So here, because I haven't installed it on my system, and this is the first time because I'm using this system. So just press, the install button. Okay. Now we are waiting for our library to install. See here, it's just the installation is in progress. Now just easily close the library manager. Again, to close it, you go to the tools and you go click on the manage libraries. So this is how you can close the library manager. Now just go and import the libraries. Okay, the first library that I want to import, and just the one thing, guys, you already know how to import a library in Arduino IDE. It has a constant part. The constant part is hash include, okay, and then open and close, this greater or less than sign, and in between these two signs put a dot h. Okay, so dot h, and before this dot write the name of your library. Okay, so this part, this is a constant part of importing each library. So because, as I told you, we have two libraries, I will just simply copy this line and paste it because it's a constant part. So for the next library, I just easily type down the name of the library without just type this whole path. So the first library that I want to import today, it's called, with the capital W, it's a wire. Wire.h, it's an I2C communication library that's required for any I2C devices that you use, not only your LCD. So if you use, any I2C device, you have to import this library, okay, in order to communicate with the library, okay, with the I2C library that we import later. In the next line, you have to import this library. So one more time, if you use any I2C devices, you have to import this wire.h library, okay? The next library, what is the next library? The next library is the library that we installed just now. It was liquid crystal underline I2C. So let's just call the library. I'm gonna say liquid crystal, and in order to call your library, you just have to type down exactly the name of the library that you installed it. So liquid crystal I2C, underline I2C.h. And this is the library that makes it easy to control, I2C LCDs. Okay, so this is our LCD library. And in the next line, guys, if you can remember, for example, in previous lesson, in the radar lessons, we had a servo, and when we were importing the servo library, we had to create, a servo object in order to use it in our main loops, in our functions later in program. So we do exactly the same thing with our LCD. So we have to create, an LCD object, and I'm gonna call it like LCD. Okay. In order to create that object, LCD object, you know how to do that. First, we have to just use the library name. I'm gonna say, just go here, guys. Instead of, you can type it down, or you can just select this part and copy paste it. It's very easy. I'm gonna just type it down. I'm gonna say liquid crystal underline I2C. So liquid crystal I2C. Now let's give a name to our object. I'm gonna call it LCD. Okay, this is the name. It's a name, just guys, that I picked for our LCD today. You can just use another name. It's completely up to you, but liquid crystal underline I2C should be exactly the name of the library that you want to call the object from that library. Now here inside of between these two parentheses, I have to pass it, three arguments. The first argument, guys, is the address of the LCD. Most common addresses for the LCDs are 0x27 or 0x3f, okay? So, but for today, for the LCD that we have, the address is 0x27, okay? So I told you one more time, most common addresses for the LCDs, they are 0x27 or 0x3f. Let me show you here. So 0, we have two addresses. So you're either using 0x27 or you're using 0x3f. Okay, so it depends. So you have to just adjust this. If your LCD won't work, or if you see an error, you have to come and change this address. So this is not just what we write down. I mean, it's not a magic thing, guys. It's just an address for your LCD. So for most LCDs, 0x27 or 0x3f. Now for our LCD today, I am just first, let's use 0x27. If we just see any error or if we see that our LCD doesn't work, we can come back and change it to 0x3f. So I said three arguments. So the first argument was for the address. What about the other two arguments? The other two arguments, the first argument will be the number of the columns, I mean the characters per line that you can see on your LCD. And the third argument will be the number of rows. So today our LCD, as I told you in when we were just setting up the hardware, our LCD is 16 by 2. It means our LCD has 16 of columns and 2 rows. Okay, guys? So these are, the meaning of the three arguments that we have to pass to our object. And one more thing, I just want to, before going to our main loop, I just want to create, a string variable to just accumulate, characters that we receive over the serial from Python. Okay, so and first of all, at the beginning, it is empty, and when we just send the command or send the text from Python, we will update it automatically in our main loop. Okay. So one more time at the beginning, I want to just, create a variable to just accumulate characters that I receive over serial from Python. So let's just call it, for example, I'm going to call it, and it is a string, guys. First of all, let's just, the data type of this variable that I want to create is a string, because we receive a string, we receive text from Python, so it is string. I say string, but see, I made a mistake, guys. String, okay. So string, and now I'm gonna say the name, let's say incoming. Okay, so string incoming. As I told you at the beginning, it's empty. Okay, so 2 quotation marks and semicolon. Don't forget, guys, semicolon. And don't make mistake. After the library names, you don't need to use semicolon. I mean, don't use semicolon. Just after, for example, the variables and, other things that you created, you have to use semicolons. But after the library names, this is the exception. You don't need semicolon. So string incoming, okay, this is the name of empty variable that I created. Nothing else left. I don't need to just import or just create anything else here, guys. Let's just go to our void setup, to the next section. In the void setup, the first step is to just, as usual, start the serial communication. In order to do that, I'm going to say serial.begin, okay, which baud rate, 115200, semicolon, okay. Next, what should I do here? I have to just I have to initialize the LCD. How I can initialize it? In order to initialize it, let's just LCD, the object that I created. This is the object that I created from the LCD library, so I have to use that object. So LCD dot init, open and close parentheses, semicolon. So with this line, I just initialize the LCD. And now, because my LCD has a backlight and I want the backlight to always be on. So in order to just turn the backlight on, I can say go to the next line, LCD dot, let's say backlight, open and close parentheses, semicolon, backlight, here it's a built-in function, init also a built-in function. These are all, built-in functions, guys. One more thing, I want to say, for example, I want to set our cursor, for example, from the 0 column and 0 row. I mean, at the beginning. So in order to do that, I can say LCD dot set cursor. Okay, let me put the semicolon first so I won't make mistake. So set cursor. Now I'm gonna say 0, 0. It means 0. Column 0 and row 0, top left corner of our LCD, and let's just print a message file when we just run the program. For example, in order to make sure that our LCD is working properly, let's print a message. So I'm going to say lcd.print, and I want to print like system ready, semicolon. Okay, this is the message, to make sure that everything's work well and our LCD is turning on. That's why I want to print this message. And this is for the, the setup function, the initialize LCD and serial, everything. So we don't need to do anything else here because we don't have anything else. We only have our LCD today. Let's go to the loop function. We need to receive the serial data from the Python. In order to do that, this loop, it continuously checks if any serial data is available. So how we can do that? Let's just use let's use a while loop here. So I'm going to say, for example, while, let's go, at the beginning. So while, I'm going to say capital S, serial dot available. That available is a serial dot available. This is a built-in function. As I told you, it checks, continuously. Why continuously? Because we put it in a while loop and in the void loop. So it checks, that if any serial data is available. Okay, but what if the data is available? If there is data available, we have to read, one character at a time. Okay. So how we can read the data from our Python? Okay, so be careful, guys. When you just using any while loop or any loop inside the Arduino IDE, you always have write your condition between two curly brackets. Okay, so while, and I'm gonna see char. Char. It stands for character. It stores, a single byte of data, which typically represents a letter, digit, punctuation mark, or even, control character like the new line character you already know, the /n. In C++ and Arduino, a char or char can hold, any value from -128 to 127 signed, or if you're using unsigned, it can store from 0 to 255. So I said I want to just read the data, because with this here, I said if any data available. And now see if there's any data available, we want to read it. In order to read it, I will just create, for example, a new variable, and I'm going to call it C. C, it's because it's very simple. It's only one letter, and in future lines, I can easily just use this C instead of just writing the whole line. So C, it's just the name of the variable. So you can just use another name. Okay. So char C. Now I want to read. In order to read, I can say, serial dot read. Okay. Open and close parentheses and semicolon at the end. Okay. So I said char C equal serial.read. With this line, what this line serial.read does, it returns the next byte of incoming serial data as an integer value. However, we just intend to treat that byte as a character because, you know, here we said char, and as I told you, it stands for character. So by storing it in a character variable like this, we explicitly tell the Arduino, this is a character, not a number. This makes the subsequent comparisons, you know, and string building work correctly. Okay, so after I read the data, but you know, for how long I want to read the data and when I want to just reset my LCD. You know, I want to tell my program, if you find, you know, for example, next line character, I mean the S/N, just clear the LCD and just reset the LCD and go back again, write down, print something new on LCD, okay? So I want to say, if you see S/N or new character, new line character, just reset the LCD. How I can do that? I'm going to use an if condition. I'm going to say if, now I'm going to use my variable name C, if C equal to, what is the, you know, new line character? The new line character is S/N. So I'm going to say if C equal to S/N. So be careful, guys. In order to write your condition, you have to write it down between open and close curly bracket. I'm going to say LCD dot clear. Let's say LCD first. Let's say LCD dot clear. What I have done so far, one more time, you know, we encounter a new line character by this one, by this if condition S/N. That, you know, signals the end of a message. So this S/N, this is a signal that means that this is the end of a message. And what we're gonna do when we see this signal, we just clear the LCD, and then what we're gonna do, again, we want to set the cursor. I'm gonna say LCD dot set cursor. Okay, again, let's say 0 to 0, semicolon. And let's just print a message after that with this line. Just let me tell you, LCD cursor, you know, we clear the LCD first with this line, and we set the cursor to the first line, and we want to print a accumulated, for example, string. Let's say sorry, LCD dot print. What I want to print now, it's time to update my the empty variable that I created above, that string incoming. I'm going to say incoming, okay? And after printing the accumulated incoming string, now we have to just reset the incoming and to an empty string. I mean, again, we want to just make it empty and prepare it for the next message. So how we can oh, I forgot the semicolon. Okay, how we can reset that? Again, exactly like the like what we did, you know, above. Incoming. Now we will just, you know, make an empty. Okay, incoming. So incoming. This is how we can just reset our incoming string. Okay. So this is our if condition. We said if you just see the new line character. You know, this condition was for the time that the new character was a new line. But what if the new character line is not, if the new character is not the new line character? So what can we do here? It's very easy. We just need to append the character to the incoming. How we can append it? So now let's go to the next line. So this is for the incoming condition, the curly bracket. This is the curly bracket for this condition. Now let's just delete this line. Okay, it goes. Let's press tab. Just be very careful, guys, about these curly brackets. They are very sensitive. Okay, so this is this open and curly bracket. This is for the if, and now I'm going to say else. Else means if the new character is not the new line character. Okay, else what gonna happen? Again, open and close curly bracket. Now I want to just append it to our incoming. In order to append it, you have to use, you know, plus equal C. But be careful, guys. It's not like Python that if you add, extra space here, it will be okay. No, you will see an error. If you can remember, if, we did the same mistake in previous lesson. So be careful about this, guys. Okay. So here we just said if the character is not a new line character, we just append the character to the incoming. This allows us to receive messages of any length, up to the LCD's capacity that it is for our LCD. It's 16 characters per line. So what about if it will be longer than 16 character per line? Longer text will be truncated or wrapped depending on the library. This is a simple but robust protocol. Messages are terminated by a new line. Maybe you want to just use another method, or maybe you know something else. Please let us know. Maybe we can use it in our future lessons. And the LCD updates only when a full line is received. So what else I don't think that we need to do anything else here, guys. We can just simply go to the Python environment, and the Python environment is very easy. Okay, so let's just open, before that, let's just save the sketch, save the code. Let's give it a name, for example, let's say LCD. Okay, LCD part 1. Okay, save it. All right. So LCD part 1, and but it's not compulsory, guys, but it's just in order to make sure that your code is okay. Just press the verify button here to see. See, we see that no such file. It says but we installed this library. Let's go to the library and let's see liquid crystal I2C. Okay, so what will happen now? We install. Okay, guys, just see, it shows that it's installed. Okay, you can see this library I2C by. Okay, let's just remove this library, guys. This by Iskak Fatoni. Just remove it. Okay, click on yes. And go to the top one and liquid crystal I2C, by Frank D. Brabander. Let's just install this library. Okay, successfully installed library. Okay, let's just close our library manager and verify our code and see. Sorry, the first step, just connect your Arduino board. Sorry, I think I forgot to just connect the USB cable to my board. So let's just try that way one more time, guys. So remove this library. Okay, I am curious to say why it was not working. So install this library. Okay, so it's installed. See, so it has been installed. Now let's verify it. Oh no, I don't know. Okay, so let's remove this library one more time, guys. Okay, go to this Frank D, Brabander, and install it. Okay, close your library and verify your code. Okay, all right. So see, done compiling, and thankfully we don't have any problem, guys. But be very careful, guys, about this liquid crystal I2C library. We just removed the previous library that we installed, and we installed a new library. Be very careful, guys. Let me show you one more time. Okay, maybe you're gonna make mistake. So see, the first library by Frank D. Brabander. This is the library that we use, and we verified our code. See, done compiling, and everything works well. Okay, so let's just go to the Visual Studio Code and create a new file for our Python. So Okay, I'm going to create a new file and I'm going to call it LCD like port1.py. Okay, this is the new file for today. The first step is, you already know, we have to start with our import. We import serial, the first thing, in order to connect with our Arduino board, and we need to import time library. Okay, now let's just open the serial port, okay, and communicate with our board. So in order to do that, I'm going to create a new variable, call it ser. Now let's gonna serial that capital S, okay, and let's say I'm connected through CAM5, okay, and baud rate of 115200, and let's just, after that, let's time sleep that K2. We added this 2-second delay, to allow the Arduino to reset after serial connection. It prevents, the startup data loss. That's why I add this slip. After that, we don't need to do anything else. Let's just go directly to create our main loop. I'm gonna say while true. So today I'm gonna wrap it like, when we were just coding in Python Mata environment. We wrap everything in our try and except block in order to create, emergency button. For more safety, guys, I said safety is coming first. So I'm going to say try. And let's just ask the user to enter something. For example, enter a text. I'm going to create a variable. I'm going to call it MSG, stand for message, for example, MSG. And I want to ask the user to input something. So I'm going to use input function, input. In the input, I'm going to ask, for example, enter text, column, and a space. So I ask the user to enter something, for example, enter text. Right now, let's just send this message, this input that we put it in a variable. Let's send this variable to our Arduino, but we add a new line character with this. We attach a new line character to this one in order to do why? Because in this way, the Arduino will understand that, for example, this is the end of our message, and it will reset the LCD as we defined in our if condition in our Arduino, if you can remember. Let me show you guys. This is our Arduino IDE code. Here with this line, we said if if the data that we receive from Python, if it is equal to s/n. S/n is the new line character. So and then we just defined the function, the if condition. We said just reset the LCD, set the cursor again to 0, 0, and other things. So now let's just say ser, right, in order to send the data. Okay, so I said ser.write. What I want to send to Arduino IDE, I want to send the message. Okay, but plus what? Plus this s/n plus the new line character. And at the end, be careful, guys. We have to just use, to encode it. Okay, so dot encode, but we open these parentheses here, but we have, see guys, we made a mistake. You have to write everything, inside between two parentheses. The right, after the right, the whole right function, the argument should be between two parentheses. But I just made a mistake. I opened the parentheses here, but I forgot to open another one for message plus s/n. So that's why I made a mistake. And what else we wanted? Just about this encode, this does encode. You already, because we used it, previously, this is a Python string method that converts a string, into a sequence of bytes, because serial communication sends raw bytes. It doesn't send any text. So before sending a string over the serial port, we must encode it into bytes. How we can encode it to the bytes? We can encode it, by this built-in function, by this dot encode. In order, for example, our Arduino can understand it, can understand this text that you enter here. You have to encode it. You have to put it, for example, in bytes. So how you can convert it to bytes? You can use this, dot encode. Okay, so we converted here. And at the end, we don't need to do anything else, guys. Let's just create our except block. So I'm going to say except keyboard interrupt. And if you, for example, press Ctrl C, I'm going to say we will break the loop. Okay. We don't print any, because it's a very simple, you can just, instead of break, you can print a message before breaking. You can print a message for the user, for example, say program stopped or anything else. But, today, because it's simple, I think you don't need to do that. Nothing else left. Now let's just go and run the program and see what's gonna happen. So let's first upload the Arduino code on our LCD. So I'm gonna just upload the sketch. See what's gonna happen. Oh, see, system ready. Oh, I think, yes, system ready. Okay, this is the message that you can see, guys. Hope you can see clearly. I thought I made a mistake, but no, it's okay. So system ready. See, this is the message that we said when we run the program. We want to see this message first. For how long? Until we receive a command, okay, from Python. Now let's just go and run the Python code. Okay, see, enter text. Let's, for example, say hello world. Hello world. And print it. That's great, guys. See, hello world. So you can see the message on your screen, on your LCD. That's fantastic, guys. This is the first time that we are just, sending data from Python to Arduino, and we tell the Arduino to do, for example, this. We tell the Arduino to, for example, print this message on LCD. Let's try something else. For example, let's say Scania, as I love Scania. Yes, that's great. Scania. See, this is the message, and let's just write, for example, a little bit, long message. I'm going to say engineering in motion, the name of our, yes, engineering in motion. See, guys, because it's only 16, I mean, there is only 16 columns. So it doesn't show anything more, but it's okay for us, guys. It's okay for our project. So engineering in motion, yes, that's correct. It shows that everything works perfectly, guys, and there is nothing wrong. Nothing, we don't need to try anything else because already it is doing perfectly. Let's print, for example, again, let's say Arduino. Okay, see, Arduino, and let's say this time Arduino and Python. See, guys, Arduino and Python. This is the character. That's worked perfectly, guys. It doesn't have any problem or we don't see any error. This is it. Today's lesson, it was, as you can see, it's very simple. It was simple. And let's, oh, I forgot to check the Ctrl+C. So let's press the Ctrl+C here. Okay, yes, see, it just break the loop. Okay, so everything works perfectly. Hope you just liked today's lesson. And as you can see, it was completely, simple. It was just, we connected our LCD, we initialized it, and then we send this is the first time that we are sending command from Python to Arduino. And in the future lessons, we will just do much more, advanced and complex projects. Just don't forget, guys, and don't hesitate if you have any question or if you have any doubt about today's project. Please let me know. Hope you liked it, and see you in the next lesson.